Assalamu alaikum dear students, and welcome back to multivariable calculus series. In previous lesson we studied the dot product and learned how it helps us find angles between vectors and compute projections. Today we'll study another important vector operation which is called the cross product. So unlike the dot product which produces a scalar, the cross product produces a new vector, and this new vector has very special property. It is perpendicular to both original vectors. Cross product plays a major role in physics, engineering, computer graphics, robotics, and calculus. By the end of this lesson, you'll be able to compute cross products of vectors, understand their geometric meaning, determine perpendicular and parallel vectors, find areas of parallelogram and triangles. Also, you'll be able to find volume of parallelepiped, and you will also learn to use the right hand rule to determine the direction of the vector generated by cross product of two vectors. Let's begin. Suppose we have two vectors in space u and v. The dot product tells us how much one vector points in the direction of another. But sometimes we need a vector that is perpendicular to both, like determining the orientation of surface, or in calculating torque in physics, or finding normal vectors to planes. So this is exactly what the cross products provide. So if we have two non-zero vectors u and v, and let theta be the angle between these two vectors, then cross product of u and v, u cross v, is defined by magnitude of u times magnitude of v times sine of angle between the vectors, and for direction we multiply this by the unit vector which is perpendicular to the plane containing both the vectors u and v. Theta lies between 0 and pi. So next important question is that there are two possible perpendicular directions. So how do we know which one is correct and which one is the direction of u cross v? So the answer is the right hand rule. Right hand rule tells us to point the fingers of your right hand in direction of u, curl them towards v, your thumb points in the direction of u cross v. So if you have these two vectors u and v, then u cross v has this direction, where v cross u has this downwards direction. You can also understand this idea of direction of cross product by this animation. Point the fingers of your right hand in the direction of A, curl them towards B, then your thumb is pointed towards the vector C, which is perpendicular to both A and B, and this is the direction of A cross B. So this is another view to understand the direction of u cross v, or cross product of two vectors. So this is another view, and you can see when both the vectors are parallel, you don't see the parallel the purple vector. So this purple vector actually is the vector in the direction of u cross v. So when you don't see the purple vector, that is both the vectors are parallel, and angle between them is either 0 or pi. And we know that sine 0 is also 0 and sine pi is also 0. So that is why when both the vectors are parallel, cross product is 0. You don't see any vector in purple color in this case and in red color in this case. So let's have a better understanding of right hand rule with this picture. Point the fingers of your right hand in direction of A and curl them towards direction of B. Then this thumb indicates the direction of A cross B. I hope it makes sense. So two vectors are parallel as we discussed earlier when their cross product is 0, because in case of parallel vectors either angle between them is 0 when they have same direction, and if they have opposite direction then angle between them is pi, and sine of 0 and sine of pi both are 0. So this makes cross product equal to 0. So if vectors are parallel, then the cross product is 0. So few useful results are shown here. If we have unit vectors I, j, k along x, y, z axis respectively in space, then I cross I is equal to I magnitude times I magnitude times sine of angle between I and I, which is 0, and times vector perpendicular to I and vector perpendicular to I and I. So since sine 0 is 0, so this becomes 0. I cross I is 0. Similarly, j cross j is 0. So these are parallel vectors with theta is equal to 0. K cross k is also 0. In short, u cross u is 0. Similarly, if we have perpendicular vectors I, j, k, and these are perpendicular to each other. So if we are required to find I cross j, then this is I magnitude times j magnitude times sine of angle between them, which is pi by 2, times the unit vector which is perpendicular to both I and j, and that is k. So sine pi by 2 is 1, I magnitude is 1, j magnitude is 1. So we have 1 into sine pi by 2, which is also 1 into k. So it means I cross j is equal to k. Similarly, j cross k is equal to I. K cross I is equal to j. And this is the positive orientation I, j, k. So if you are required to find I cross k, then this is equal to negative j. So this direction is positive. I, j, k. This is the cycle. I, j, k. I cross j cross k cross I. These cross products have positive signs, and if we change the direction, then we get negative sign. That is, j cross I is negative k cross j is negative I, and I cross k is negative j. If we have vectors in component form, u is equal to a1i plus b1j plus c1k, b is equal to a2i plus b2j plus c2k, then their cross product is the cross product of right hand sides. And by distributive law, a1 a2 I cross I, similarly a1 b2 I cross j plus a1 c2 I cross k, and similarly we have b1 a2 j cross I, b1 b2 j cross j, b1 c2 j cross k, and plus c1 a2 k cross I, c1 b2 k cross j, and c1 c2 k cross k. So after a couple of simplification steps, we have this b1 c2 minus b2 c1i plus a2 c1 minus a1 c2j plus a1 b2 minus a2 b1k, and this is nothing but this determinant. So u cross v can be written in determinant form as I, j, k makes first row. Second row consists of the components of u, first vector, and third row consists of components of second vector. So there are few more properties of cross product. If we have u, v, w, three vectors, and let k be a real number, then u cross v is equal to 0 implies either u is 0 or v is 0 or u and v are parallel. We have already discussed this. U cross v is equal to negative v cross u, and this is distributive property. U cross v plus w is equal to u cross v plus v cross w. You can prove all these properties by yourself. U times scalar multiple of v is equal to scalar multiples of u cross v. I mean, u cross scalar multiple of v is scalar multiple of u cross v. U cross v is equal to 0. So this is the property of parallel vectors. U cross 0, one of the vectors is 0, then cross product is also 0. There is another property. Since we know that u cross v is perpendicular to u and v both. So we know that if two vectors are perpendicular, then their dot product is 0. So dot product of u and u cross v is 0 because both are perpendicular. Similarly, v dot u cross v is equal to 0. And this is also because both the vectors are perpendicular. Let's have two vectors with same initial point, and let theta be the angle between these two vectors, and let's make a parallelogram with the help of these two vectors. So this is the parallelogram. This side is of course parallel to v, and this is parallel to u, and magnitude of opposite sides. So this is the parallelogram constructed by the adjacent vectors u and v. Now we are required to find area of this parallelogram. We know that area of this parallelogram is v magnitude times this height, right? And this height is, if this angle is theta, so this is height, this is perpendicular to this side. So this angle is 90 degrees or pi by 2 radians. Then h, by using trigonometric ratios, h over u magnitude is equal to sine theta, right? So h becomes u magnitude times sine theta. So let's substitute this value. Area of this parallelogram is equal to u magnitude times v magnitude times sine theta. And this is actually magnitude of u cross v. So we have a result. If we have u and v, two non-zero vectors in free space, and let theta be the angle between these vectors, and they are positioned so their initial points coincide, then the area of the parallelogram that has u and v as adjacent sides is u cross v magnitude. Because this is area, and this area is equal to u cross v magnitude. So if u cross v is 0, if and only if u and v are parallel vectors, that is if and only if they are scalar multiple of each other. So there is another definition which is called scalar triple product. It involves three vectors, and it involves dot product. It also involves cross product. So this is defined by u dot v cross w, and is called scalar triple product of u v w, and it is defined by this determinant, and we can prove it because we know that if we have vector v with components v1, v2, v3, w with components w1, w2, w3, then v cross w is in fact replace these u1, u2 with I, j, k, Now, this is how we can write u dot v cross w. This is v cross w, and their dot product is, now replace u by u1i plus u2j plus u3k. Then dot product is u1 times this, u2 times this, and u3 times this, right? So this becomes this, and this is actually equal to this determinant. Now, geometrically, this magnitude of this dot scalar triple product is volume of the parallelepiped constructed using these vectors u, v, w. So let's have three vectors with common initial points. So this is vector u, this is vector v, and this is this is vector u, this is v, this is w, right? So this base of this parallelepiped, and construct the parallelepiped using these vectors. So base of this parallelepiped is a parallelogram, this one, and its area is v cross magnitude, right? Now, volume of this parallelepiped is base area times height. Now, what is height of this parallelepiped? This is projection of this vector u on v cross w, okay? Scalar projection of u on v cross w. And we know that scalar projection of u on v cross w would be u dot v cross w divided by v cross w magnitude square times v cross w magnitude, and this is equal to this. We have learned this in the previous lecture. So if you are confused in any of the steps, you can go and check how to find scalar projection and vector projection of one vector upon another vector. So this is height of the parallelepiped. So volume of the parallelepiped is area, base area times height. So base area is the magnitude of cross product of v and u, and times height. Height is given by this. So if we multiply this by v cross w magnitude, we'll be left with u dot v cross w. This is magnitude of scalar triple product of u, v, w. So cross product of two vectors actually represents the magnitude of cross product of two vectors represents the area of parallelogram with both the vectors as adjacent sides of the parallelogram, and similarly scalar triple product represents the volume of parallelepiped that has u, v, and w as adjacent edges of this parallelepiped. So let's have a look at the visual display. So if we have vector u, another vector v, then their cross product is the vector h, which is in blue color, and this is the parallelogram made by vectors u and v as adjacent sides. Let's have another vector w, then construct all the faces of the parallelepiped made by u, v, w as adjacent edges. Here we go. This is the parallelepiped, and its volume is u dot v cross w. Now u dot v cross w is equal to v dot u cross w. So we know that u dot v cross w is determinant u1, u2, u3, v1, v2, v3, w1, w2, w3. So if we interchange two rows once, then we'll have negative sign. But if we interchange two rows twice, then the determinant value will remain same. So you can see that u dot v cross w is equal to v dot u cross w. Similarly, this is also equal to v dot w cross u, or this is also similar to the idea u v w, right? So u dot v cross w, w dot u cross v, similarly v dot w cross u. So if direction is this cycle is counterclockwise, then the value will remain same. Otherwise, it will have negative sign. So conclusion of this discussion is that u dot v cross w is u cross v dot w, and u dot v cross w is equal to v dot u cross w, and so on. Last, in conclusion of this section, we can say that dot and cross products are coordinate independent. They do not depend, or their value do not depend on the coordinate system, because if we have two vectors and we have angle between them, then we can find dot product and cross product with the help of that angle. So u dot v is magnitude of u times magnitude of v times cosine theta. Similarly, magnitude of u cross v is u magnitude times v magnitude times sine theta. So that is all for this section. Like, share and subscribe, and follow the channel for further updates. So see you next time. Till then, take care. Bye.